Right. Uh, Hello. So this is our Group E, and this is our presentation on solid waste management report. Our group members are me, Muhammad Asshidiqie, and
Me, Aryo Nugroho.
And me, Dave Alexander Montolalu.
Right.
okay. So moving on. Uh, we have our DRO in the screen right now, and the objective that we have been given is that we are supposed to generate a proposed solution up to the prototype design in terms of an engineering product that would help solve the solid waste management in Bandung City. So our task was also to to make a report based on the data we have collected from all the sources that we have took these data from. Uh, and then we have to come up with a design of a prototype and also uh, try to develop on that. So our requirement is that we have a group of three people, which is me, Aryo, and Dave. And the design must reach up to the prototype design, and us as a group have to be able to explain how it works clearly. Okay, so our design, uh, we plan to create a machine that allows us to separate organic waste from inorganic waste. And to do that, our machine has to able to recognize the difference between the two. And with that being said, we can then process both these types of waste to be able to minimize the amount of waste that is put into the landfill. Why we make the separator in relation to Bandung's condition? We decided to make the separator because we know that Bandung has a problem not in the sense of recycling the waste itself, but in managing the waste which could be reused again. Because there is limited separation in the waste. The trash which comes in the TPU couldn't be used.
All right. Moving on to the conceptual design. So first of all, we have created three alternative designs. And the first one is using strong magnets to attract the waste in the conveyor belt and then manually separating the waste after that to categorize non-organic materials. So our first design here only uses the method of magnets, and that's only to take the waste that are like metals and stuff like that. And we don't use this design because we still have to use manual labor, and it doesn't really separate the inorganic and organic substances. For our second alternative design, the design uses the trash separation using sieve, so it separates the trash by size. Then after that, it uses eddy current separator to take out metals in the big trashes, and lastly, after that, using centrifuge to sort the trash by density. So why we don't use this design also is because the trash is separated by size, which is not really what we want, and we thought that using a huge centrifuge, is a lot of money, and I don't think it's really realistic to implement a lot of money to the stress management in Bandung. And our last alternative design is by separating it purely by using density. So why we actually want to use density is because it's it's really a high yield separation. So we really know which trash is which, and it can separate the trash in a detailed manner. But then once again, it's very expensive, so we don't use it. So after all the brainstorming, we chose to incorporate all three designs, and this is our last design. So firstly the waste goes through here, and then it goes through the conveyor belt. If it first goes through here and it falls down, goes through the conveyor belt, and there's actually current here which creates magnets so that it could attract metal waste through here. So the metal waste are separated here. Then the remaining trash is being separated here, which is the water filter. The water filter will later separate the trash by density so that it could differentiate which is the organic and the organic substances. So yeah.
Now I'm going to talk about the detailed design. First, the design. Our design characteristics is that we separate the three types of waste, which are metal waste, plastic or inorganic waste, and also organic waste. These separations could be beneficial for recycling the waste or could be sold to waste recycling companies. The design principle in our design mainly uses two principles. The first one is electricity and magnetic principle, which comes from the eddy current separator. And the second principle is that it uses density to separate between the plastic and organic substance. Lastly is the design modification and improvement. We modified our design from three designs that were in the beginning to create our newest design. After that, we made the following improvements. First, we added a conveyor belt for the waste, which were the metals. Second, we made a water filter, now uses a trapdoor function. And our initial design was only to extract organic substances. Now it could extract organic, inorganic, and metal.
Okay, so we're moving on to our prototype design. Here we have a drawing of the side view and the top view, and we will talk about the size of the actual design. We wanted to make it big as Bandung is a big city and has a large amount of waste produced in about a year or even a month. It can produce a lot of waste. So we've made the dimensions of this machine pretty big to be able to handle the amount of waste that is actually being produced. So uh, we have the side view from the left, and then the middle drawing is the top view, and the one on the right an is an extra view of the water filter that is not seen in the side view and the top view, and the one at the bottom is the sketch of our whole entire machine.
Alright, moving on to the mechanism. This is how the machine actually works. So the trash comes down on a conveyor belt in a thin layer of mixed waste. It will then reach the end of the conveyor and come into contact with the eddy current separator, which is incorporated in the conveyor belt itself. The separator will separate ferrous metals from non-ferrous metals and non-metal waste, such as organic waste, plastics, and etc. So the first function of the eddy current separator is actually only to separate metal waste from non-metal waste. And the non-metal waste, or the non-metal trash, is then submerged and separated by density, which is done by the water filter, which is seen here. And each different types of trash will then be sent to different places for them to be reused or disposed of. And so this is uh, the layout view of what's happening. Basically just summarizes the first paragraph.
Now to talk about the product design description as well as its implementation. For the description, our product separates waste materials. We chose this because waste in Bandung can have great potential to be used in other fields. However, the problem lies within separating the waste itself. So to solve that, our device was made so we can separate it into four different types of materials. non-ferrous metals and ferrous metals, non-metal organic waste, as well as organic waste. After that, for the implementation, our product is designed to be implemented in places where waste is compiled so that the mixed waste can be separated instead of just being thrown away. This should help automate the separation of waste so that instead of just getting rid of all the waste, we can reuse it in different fields according to the materials.
For the reflection, we have our lesson learned and possible improvement. So, the lesson that we learned by doing this project is that we are able to improve our skills on things such as collecting data. And as we are able to improve this skill, we would be able to collect data more efficiently, and we can apply this skill onto the design that we would have to make next. The second lesson learned is that this project teaches us to improve on the designing methods of engineering from the very first step till the very end. And this project also allows us to be able to think critically in a way to be able to come up with multiple designs and not just one, and decide which one of them is suited best to the requirement, and also to develop the design with the multiple designs that we have created. The possible improvement is that we should find a better way to separate organic and inorganic, as we don't really have that in our machine right now. And the eddy current only works on smaller sized waste. A possible improvement is to find a way to sort the larger sized waste material.
So this is the chances of implementation. For our design, as it is a big machine, the chance of implementing this will be in places that do have their waste management as their main priority. As the machine is big as well, it will take a lot of electricity to power it up. Therefore, making sure that the machine is put in place that has sufficient electricity is important. That's why we have plans to implement this design in TPU so that the trash that goes into TPU could directly be separated. And because TPU is focused mainly on trash itself, then it would make sense for us to implement this machine. As our design focuses on separating waste in terms of type, it allows the waste to be reused or recycled, especially the organic waste and the metals. So places that are running out of resources could implement this design to help them be more efficient in terms of use of resources. This design could also be implemented into cities that has a magnificent number of people living in it, as that would mean the city would produce a lot of waste. As this design is designed to tackle a large amount of waste, it would be a good use for that. So I think that Bandung is a really good place to implement this machine because Bandung, first of all, has a lot of waste because there's a lot of people in it, and Bandung actually has a problem in separating the waste. So our machine technically tackles the problem that Bandung really needs, which is separating the waste itself. As for uh, managing the organic and inorganic waste itself is actually already pretty good in Bandung, so we don't really focus in that. So yeah, that's for everything.